Good morning, everyone. I'm Dr. D. Madhavi, and today I'm going to discuss bubble sort, one of the sorting technique in data structures. So all of you can understand what is a bubble is. Here you can see a child enjoying the bunch of bubbles. The bubble sort is also known as the ripple sort or sinking sort. It is probably the first reasonably complex program that any beginner, any programming beginner has to write. It is a very simple construct which introduces the student to the fundamentals of how sorting works. A bubble sort makes use of an array and some sort of swapping mechanism. Most programming languages have a built-in function to swap elements of an array. Even if a swapping function does not exist, only a couple of extra lines of code are required to store one array element in a temporary field in order to swap a second element into its place. Then the first element is moved out of the temporary field and back into the array at the second element's position. A simple example of how a bubble sort works is, suppose you have a row of children toy blocks with letters on them. They are in random order and you wish to arrange them in alphabetical order from left to right. Firstly, you have to begin with the first block. So suppose there are three blocks G, A and Z. So look at the block just to the right of it. So G and A, if you compare these two adjacent blocks, A is smaller than G. So you perform a swap and you can arrange these three blocks as A, G, Z. So the next one is in alphabetical order and no swapping required, and the last one is also in alphabetical order, so no need to swap. So this is how the bubble sort progresses. The bubble sort gets its name because elements tend to move up into the correct order like bubbles rising to the surface. If you pour some soda into a glass, all the large bubbles first try to move to the surface, and then other smaller bubbles will follow it. Similarly, in bubble sort, the largest element will move to the end of the list and then tries to occupy its proper position. So here is a simple algorithm here. Compare pair of adjacent items, swap if the items are out of order, and repeat until the end of the array. The largest item will be at the last position. Reduce n by 1 and go to step 1 for repeating. So number of times you are going to compare the adjacent elements unless all the elements are arranged in proper order. So the scan of adjacent comparisons, the scan of the list of every pair of adjacent elements in a given array from starting to end of array once is called as a pass. So depending upon the requirement, you can have any number of passes maximum n number of passes in order to arrange the elements in an order. So here the analogy is the large item is like a bubble that floats to the end of the array. So this is the given array containing 5 elements, 29, 10, 14, 37 and 13. So first I am going to compare the first pair which are adjacent to each other. Now 10 is smaller than 29. So I am performing a swap here. I am doing a swap here. And then 10 and 29 are swapped. And again I am going to compare my second and third elements because both are adjacent. Now 14 is smaller than 29. So once again I want to swap these two. So 14 and 29 are swapped, exchanged their positions. So now again the third one and fourth element is compared because both are adjacent. So 29 is smaller than 37, so no swap is required here in this case. So next I want to compare this fourth item with the fifth item. So in this case 13 is smaller than 37. So 37 is swapped with 13. So 37 reaches the end of the list. So one iteration is completed here. So this is called as one pass. At the end of pass 1, the largest item 37 in the array is positioned at the last location of the array. Now I will repeat the same in the second pass. So again I will compare 10 and 14. This will be taken as input now, and then 10 and 14 will be compared. They are in proper position, no swapping is required. So once again I'll compare second and third element. They are in proper position, no swapping is required. Once again I compare third and fourth elements. So 13 is less than 29, so a swap is required. So 13 is swapped here and 29 is placed in the last but one location. So there are no more elements to compare because 37 is already in the proper position and you need not again consider the last element. So with this second pass is completed, and at the end of the pass 2, the second largest item 29 is at the second last position. So the green color indicates that the elements are sorted. And this shaded, gray shaded indicates the pair of items under comparison. So similarly, you can repeat this with another pass, pass 3. So in pass 3, these are in order. These are not in order, so there will be a swap for 13 and 14. So 14 will be placed and it will be given a green color. Similarly, when you compare these two, again the 10 and 13, they are in order. So 13 will be given green color and finally 10 will be given green color. And with pass 3, you can find out that all the elements are sorted. This is the function for bubble sort, and void indicates it returns nothing. And then it takes two parameters. One is an integer array in which we store the data items, and the other one is the size of the array, that is the number of elements you want to sort. So I am taking two for loops, and the inner for loop here, it compares two adjacent elements, j minus 1 and j, both are consecutive numbers. You are taking two adjacent numbers and comparing. If they are not in order, then you are swapping. So you are calling a function swap and then swapping the two items a of j and a of j minus 1. So the first iteration of the inner loop performs the testing and swapping, and it requires time bounded by a constant c. There are two nested for loops. If you observe this function, there are two nested for loops. And the outer one repeats exactly n times. And the inner loop, it varies. Maximum it can repeat for 0 to n minus 1 times. That is, again it is 1. So the total number of iterations is equal to 0 plus 1 plus etc. n minus 1 can be represented as n into, this is the outer loop and this is the inner loop, and n into n minus 1 by 2. So the total time is equal to C into some constant into this one. If you can neglect all the constant values, you have a quadratic time, that is order of n square time complexity for this bubble sort. So bubble sort is inefficient with a time complexity of order of n square. However, it has an interesting property. What is that property? Given the following array, how many times will the inner loop swap a pair of items? So here the elements are in ascending order. Already the elements are in order. In this case, how many times the inner loop will repeat its operation? So it doesn't repeat because everything is in order and no swapping is performed. Single swapping is also not performed. So if you go through the inner loop with no swapping, the array is sorted and can stop early. It can stop early. So again, it depends on the type of the data that is used. So if you assume by taking another variable is sorted, which is of Boolean type, and you are initializing it to true before the inner loop, and if it is true, it indicates that the array is in ordered form, that is sorted. And whenever you perform a swap operation, then is sorted is made false. Any swapping will be invalidating this variable is sorted. So at the end of the inner loop, after coming out of the inner for loop, first we check if is sorted is true or not. If it is true, then it returns from the function. Otherwise, it will not return. That means it has to perform all the remaining operations. So in this way, you can reduce the time if you can give the elements in an ordered way. That means it depends on the order of the input. So in worst case, however, input is in descending order. That means starting from the maximum element towards a minimum element. So again, the running time remains the same order of n square. And what is the best case? Best case is input is already in ascending order. The algorithm returns after a single outer iteration and the running time is order of n. It becomes linear because it will not enter into the inner loop. In the next class, we'll discuss about insertion sort. And thank you for your valuable time.